Hi, my name is Katie, and today we are covering chapter 13, and I am the driver for the session, and I'm here with my navigator.
Hi, my name is Ronin. I'll be navigating this session.
Okay, so chapter 13 was about, um, get to the textbook, risky behavior. So I have a short summary about what the chapter is about, and I'll just read it out. So in the chapter, it introduces us to Java exception handling. So how to write code, we can deal with runtime problems using the music MIDI music web project is the learning context. They explain that even correct code can fail due to external issues, so Java uses exceptions, objects that can represent errors to manage these risks. So you learn how to use try and catch and finally blocks to handle and clean up errors. How checked exceptions must be declared or caught, and how exception hierarchies and ordering affect which catch blocks run. So the chapter also covers stacking exceptions, passing them up to cause stack emphasis that someone must eventually handle them. Finally, they introduce Java sound and MIDI, explaining how to use the sequencer and tracks and the MIDI events to create play music, connecting the theory and handling the practical creative Java project. Okay, so basically, the highlight of the chapter was the try and catch the exceptions. So I'm going to read the importance of it, and then I'm going to dive into a code. So if so the importance of exceptions, which is the try and catch in Java, prevents your program from crashing. So without the try and catch, one small runtime problem like a missing file, network failure, or unavailable device would make the entire program stop suddenly. With exception handling, Java lets you catch those problems and decide what to do instead. So for example, it will show an error message or try again. Next, it separates the normal code from the error handling. So you keep your main logic clean inside the try block and put all the error handling or recovery code neatly in the catch block. This makes your program easier to read, debug, and maintain. It helps handle unpredictable situations. Not all errors are caused by bad code. Sometimes the problem is external, for example, a full disk network timeout or fuzzy MIDI system. So the try and catch help you gracefully handle the real world issues you can't control. So next it provides useful debugging information. The exception objects like over here, I'll just highlight it, contains the details about what went wrong. So you can use these methods like eGetMessage or ePrintStatTrace to track down and fix the problem faster. Finally, it supports cleaner resource management. So when used finally, exception handling ensures the importance of cleanup always happens, like closing files, network connections, or the sequencer. So it prevents resource leaks and keeps the program stable. So here I have a simple code that I will go over. So first of all, we have our import. I'll just highlight it over here. Here we have our import. So this line imports the Java Sound MIDI package, and then the Java XR MIDI just contains all the classes needed to work in the MIDI music in Java. Things like the sequence or the sequence in the track. So by using this asterisk over here, basically we importing everything in the package so that we can use the class directly. Next, we have our public class MIDI example. So here we defining the public class, name the simple MIDI example. So in Java, everything runs inside a class. This class is marked public, meaning it can be accessed from anywhere, which is required for the main class. Um, Next we have the public static void. So this is the entry point where where of every Java program. So the first method it runs, then we have the string args that holds the command line, which is not going to be used here, and then finally we have the static. Um, so the static just belongs to the class and not a specific object. So here we have our next line. Simple MIDI example player, new simplified example. So this line creates an object instance of the class and it thinks about building a play machine that knows how to play music. And then the new keyword calls the class constructor a method that builds the object. Next we have the next we have the player play new music. Now that we have a player object, we call this method play music. So this is where the main logic for handling the MIDI sound and exception handling happens. Okay, just see something. So here we have the play music method. So what happens inside? So here we're defining the method called play music. The void means it doesn't return anything. And this is where we'll be trying to access the MIDI sequencer, the component that plays the MIDI music. Okay, so now you can see we have our try block. I'll just highlight it like that. So the try block is where we put the risk code. Code that might cause an exception, an error that can occur during runtime. So if an exception happens inside the block, Java jumps out of it and goes straight into the matching catch block underneath over here. So going into the code, we have our first line, the sequencer over here. So we call this method the MIDI system get sequencer to request the MIDI sequencer from the system. So the sequencer is like a conductor of a band. It plays, stops, and controls the timing of the MIDI data. So this can fail if no sequencer is available or if it's already in use. And when that happens, it will throw a wait, is it? Wait, is it? Okay. It will throw a MIDI unavailable exception, basically. Next, we have the system printout line successfully got a sequencer. So if the above line works, this message will be printed to confirm that the sequencer object was created successfully. Then we have the sequencer open over here. Basically, that's just tell the sequencer to initialize and open itself so it's ready to use. Think of it like turning on a sequencer's power before playing music. This can also fail, for example, if a sound system isn't available, which is why it's inside the try block. Next, we have our next line over there. System outprint line sequencer is now open and ready to play music. So if everything went smoothly, we print this line to confirm that the sequencer is open and ready to be used. Now moving on, we have our catch block over here. Okay, so I'm going to explain it over here. So the catch. So this is the catch block that runs only if the exception occurs in the try block. So here we specify the exact type of exception we expect. In this case, we will expect the MIDI unavailable exception. Um, and the variable E over here holds the exception object that contains the details about the project. Next, we have our next line, which is the system upper print line. Oops, could not get the sequencer. So if something goes wrong, this line displays a friendly error message to the user instead of letting the program crash. Next, we have the eprint stack trace. So this prints the stack trace, a list of methods that were running when the error occurred. So it helps like developers debug the problem showing exactly why it failed. So that is it about the try and catch block. So I'm going to run it and see if it works. As you can see, it successfully ran. So just to summarize about the try and catch, I'm going to just list a few reasons why it matters. So the try block just wraps the rescue code to watch for errors, and the catch block handles the specific errors that occurred, allowing the program to recover or fail gracefully. Yeah, that's about it. So next I have an activity that I'm gonna go over if I can stop over here. True or false? So the ship to explore the wonderful world of exceptions. Your job is to decide whether each of the following exception related statements are true or false. Okay, so we have a first one. So I'll make true green and false red. Let me just highlight it over here. True will be green and false will be red. Okay, so first question. A try block must be followed by a catch and finally wait. A try block must be followed by a catch and a finally block. Um I would say false because a try block must be followed by either a catch or a finally block, not necessarily both. I'm gonna give it true. Just give me a second. Sorry about that. The next question. If you write a method that might cause a compiler check exception, you must wrap that risky code in a try and catch block. Uh, if you write a method that might cause a compiler check exception, you must. I would say false. I would say it's false because you can declare the exception with throws wrapping is not mandatory. So I'll go with false. Number three, catch blocks can be polymorphic. Um, I would say it's true because you can catch a superclass exception type that matches the multiple subclasses. Might be wrong. Number four, only compiler checked exceptions can be caught. I'd say this is false because you can catch both checked and unchecked runtime exceptions. So we're going with false over here. Number five, if you define a try catch block, a matching finally block is optional. I'd say it's true because the finally block is optional and catch alone is valid. Number six. Number six. Sorry. If you define a try catch, if you define a try block, you can pair it with a matching catch or finally block or both. That is true because you need at least one catch or finally after the try block. Number seven, let me just read it first. So, if you write a method that declares that it can throw a compiler checked exception, you must also wrap the exception throwing the code in a try and catch block. False. Declaring with rows is enough and wrapping is optional. Um, Number eight, the main method in your program must handle all unhandled exceptions thrown to it. I'd say it's false because unhandled exceptions can propagate and crash the program. Handling is recommended, but it's not required. So I'll go with false. Number nine. A single try block can have many different catch blocks. That is true because you can catch multiple exception types separately. Number 10, a method can throw only one kind of exception. That is false. A method can throw multiple exceptions. Number 11, a finally block will run regardless of whether an exception is thrown. Um, that is true. It always runs even if the exception is thrown or not. Number 12, a finally block can exist without a try block. That is false. A finally block must be paired with a try block. Number 13, a try block can exist by itself without a catch block or a finally block. That is false. A try block must be followed by a catch block or a finally block. Um, uh, number four, Number 14. Handling an exception is sometimes referred to as ducking. That is true. Ducking means declaring the exception with throws instead of handling it. Next, the order of the catch blocks never matters. False. The order does matter. More specific exceptions must come before the general ones. Number 16. A method with a try block and a finally block can optionally declare a check exception. I'm gonna say it is false. Number 17, the runtime exception must be handled or declared. I'm going to say it's false because the runtime exceptions are unchecked. Handling or declaring is optional. And that is it for chapter 13. Thank you for watching.